recording. Here we go. All right, so today we're covering section 5.1. This one is about graphing in general. First, we'll start with how you plot points. Now, this is very simple, and I even think that maybe some of you might already know how to do this, but we're going to cover it anyway, just to make sure everybody's on the same page, right? So when you're attempting to graph a point, or to plot a point, I should say, you have a grid like this, where you have the x-axis right here and the y-axis right here. Now, x values follow along the horizontal line, and the y values follow along the vertical line, the vertical axis here. Now, when you attempt to graph it, usually the point is displayed like this, a pair of parentheses with a comma in the middle, where the x value is first and the y value goes second. So first number you see is going to be x, second number you see is going to be y. This is called an ordered pair, right? Now, with that knowledge, let's try to plot these points. First one we have is 2 and 3. That means that my x is 2 and my y is 3, yes? So what we're going to do is I'm going to go here to the x-axis, which is the horizontal axis. Find 2, so 1, 2 here for x, right? 3 for y, which is right here, plus 2 and 3. You got to see where they meet. This point right here. Point is 2 for x, 3 for y. So that's my A. So that. So you grab 2 for x, 3 for y, and you find your point. Okay. Let's try B. -4 and +6. So the first one is x. So we're going to follow x. We have 1, 2, 3, 4. That's -4 for x. Now we need +6 for y. We go up 1, 2, 3, 4, 5, 6, all the way up here. Oh. You can still hear me? Okay, good. Is the camera still frozen? I see. Okay. Let me try and maybe turn it off. No, hopefully that makes it work. Right, here we go. Second attempt. Is it sharing? Nope. Ah, there it is. Working now? Or is it still frozen? Still frozen? Okay. Let me try this. Hold on until the connection is fixed. Man, what is that noise? Okay, let's try again. Here we go. Oh, come on. This is not good. Ah, all right. How are we doing now? Better? Awesome. Okay, good. All right, so where were we? Yes, we're plotting points. Did you see when I did A? Was that before it froze or after? Did you guys see A? No? Okay. So again, first value is x, second value is y. So we go to x, we count 1, 2. We go to y, we go 1, 2, 3. right? So since x is 2, y is 3, this is my point right here. Let's try B. We have 1, 2, 3, 4, 5, 6. So I need the -4, which is right here. Now, for y, it's 6. So I'm going to go up 6. 1, 2, 3, 4, 5, 6. So the point is right here. That's B. Okay? What about C? It says 0 and 2.5, 2.5. So for x, it's 0. So I'm on the horizontal axis exactly at 0, and I'm not going to move, just here. Now, I need to go for y, 2.5. So I'm going up 1, 2. This is 3. So between the two right here. This right here. That's 2.5. Okay, so that's C. All right. What about D? Okay. For D, x is -3/4. So 3/4. And it's negative. So it's in this direction. So this is 0. That's 1. This is -1. So this is what, half. So 3/4 would be right about here. And I'm plotting it on the axis because y is 0. So I'm not going to go up or down. It's on the 0 line, which is right here. Okay. What about E? We have square root of 2 and then -2. Square root of 2 is about 1.14-ish, right? So that's 1, +1 for x. And then a little bit to the right should do it. And then we're going to go to the -2. So I'm going below. 1, 2. This is where -2 is. So the point is right here. That's E. Everybody with me so far? Yeah? Okay. So what's pi? What's the value of pi? Right? If you know more than these 4 digits, then good for you. I don't. Okay? So it's 3.14. So it's obviously after the value of 3. So it's somewhere between 3 and 4. Closer to the 3 since it's just 14. Right? So right about here for the x. Now for the y, we said -4. So I'm going to go below until we're lining up with the -4, which is right here. So between 3 and 4. And it's going to be here at the line of -4. So right here. That's my f. Ta-da! Done. Questions? So plotting points is pretty simple. Any questions before we move on? All right. Next thing we're going to cover this section is a couple of formulas. The first one is called the distance formula. With this formula, we are going to learn how to find the distance or space between two different points. Notice I have two ordered pairs. Now, when you have a problem to solve, I'm going to give you two pairs. You need to label one of them as pair number 1 and the other one as pair number 2, like this. So pair number 1 is going to have the x value be x1 and the y value be y1. Over here we have x2, y2. The 1 is because this is in the first pair, 2 is because it's in the second pair. So far so good. I don't want to see you mix and match because I've seen this before. People go x1, y2. Like, nope. It's either 1, 1 or 2, 2. Yes? 1's matching the number of the pair. 2's, same thing. All right? Now, where do these come in handy? Right here in that formula. The formula says d, which is distance, equals square root of. First we have x2 minus x1. So you grab the second x and then minus the first x, the whole thing squared. Yes. Plus, now, y2 minus y1, and then the whole thing squared. So x2 minus x1 squared plus y2 minus y1 squared. That's your formula. With this formula, we find the distance between any 2 points. All right, let's give it a shot. First problem. Let's say this is pair number 1, and that's pair number 2. And by the way, if you switch, like you label this 2 and that 1, it's fine. You're still going to get the same answer. Okay? Just stick to it though. So if you make this 2 and that 1, and you start off that way, and then you go, but I want this one to be 2 now, don't do that. Don't switch mid problem. Okay? Now, d equals what? Square root of, okay, big root. Let's see. First we start with x2. This is pair number 2. X here is 3. So this is my x2, is 3. Minus x1, x from the first pair, which is negative 3. So we have negative 3 squared. So we have 3 minus negative 3. Plus another pair of parentheses. Y2, which is 0 minus negative 4. And then you square it. Okay? This equals. Now we have 3 minus a negative 3. So the two negatives basically turn positive. And we have 3 plus 3, which is 6. So we get the root of. You can understand it, but yeah, you have to memorize it, because on the test you're not allowed to use, notes or anything. So you have to know what it is. But if you understand how it works, you can figure it out in the spot. Because basically you're finding the difference between the x values and then the difference between the y values. You're squaring them, adding them, and then taking the root of it. Yeah? But if you can't internalize the concept, then memorize it. That works too. Okay? But you can't use note cards or formula sheets on the test. So it's going to be completely closed book. Okay? Now, we have negative 3 minus, 3 minus negative 3 is positive 6 squared. And 0 minus negative 4 becomes positive 4, also squared. This is my new root, which equals what? We have root of 36, which is 6 squared, plus 16. This equals root of 52. If you stop right here, I don't mind. But on your homework, it might ask you to simplify. So this can be simplified as 2 times root of 13, right? Because it's 13 times 4, the 52. Root of 4 is just 2. And approximately 7.21 if they ask you for decimals. You can use your calculator for that. Any questions so far? Everybody with me? Okay, I'm going to take that as a yeah. All right, let's do another one. Distance problem for this right here. Okay, how about I give you guys 3 minutes and you try and do this on your own, and then we'll do it together. Okay, so you have 3 minutes starting right now. I'm going to Okay, here we go. Let's do it together. Now, what answer did you guys get before we get started? What did you get the distance to be? Again, it doesn't matter which pair you used for 1 and which one you used for 2. Okay, let's just do it together. Here you go. Oh,
I got square root of 34, but I forgot how to make it like
simplify it.
make it. I'm sorry?
How to simplify it?
Yes.
Yeah. Well, you see, when it comes to simplifying roots, you basically look at the value inside, right? And you think, okay, what multiplied gives me this, right? And you think of those possibilities. And the goal here is to try and find one that actually can be solved, right? So 52, for example, is 4 times 13. Now 4 under the root is 2, right? So square root of 4 times square root of 13. And then you just solve that one and you say 2 times square root of 13. That makes sense, right? So for the 34, actually there isn't a simplification. So it's just the root of 34. All right, but yes, you're right. Okay, let's see. This is x2, which is 3.8, minus x1, which is negative 1.2 squared, right? Plus, we have 1.5, which is y2, minus 4.5, which is y1 squared. Right, this equals what? Over here we have 3.8 plus 1.2, basically, which is 5, right? Squared. Plus, over here we have 1.5 minus 4.5, which gives you negative 3. Whole thing squared equals. Now, 25 plus 9, that equals root of 34, which is approximately 5.83-ish. You can use your calculator for that. Any questions so far, you guys? Now, did anybody, oh, okay, awesome. Did anybody get confused by the 2 sign here being a positive instead? Do you guys know that rule? When you have, for example, 3 minus negative, this turns positive, that turns positive, and you add them, this is 8, right? If you have negative minus a negative, these turn positive, and you end up subtracting them, and you get positive 2 over here, right? Do you know that rule? You flip this one and you flip that one. Yeah? Okay. If you have 3 minus 5, just like normal, like this. If you flip this, you flip that, it ends up giving you the same answer, which is negative 2. So it works with everything. You can just do it all the time if you want. Yeah? So, anywho, just wanted to make sure you know that. So when you have minus and negative, then they both just turn positive when you add. Right? Okay. Let's do this one, last one. I know it looks nasty, but it's going to be fun. Here you go. So we have d, which equals root of. All right. Let's call this pair 1, that's pair 2. Now, x2 is negative root of 3. So negative root of 3 minus x1 is negative 6 root of 3. So negative 6 root of 3. And then squared. Plus, open another pair. Now we have 2 root of 6 minus root of 6. Close it, squared. All right. Now, over here we have what? These basically turn positive. Yes. And I have a negative root subtracted from 6 positive roots of the same root. So we have 6 root of 3 minus 1 root of 3, which gives us 5 roots of 3, right? Because it's a multiplication here. The 6 and 5 are multiplied. So I'm saying I have 6 roots of 3, and I'm taking 1, you end up with 5. So 5 roots of 3 squared plus. Now over here we have 2 roots of 6 minus 1 root of 6, which leaves you with 1 root of 6. Oops, I wrote 6 on top. It's squared. So far so good? Now, when I square this, I'm just gonna square both. So 5 squared is 25, right? And root of 3 squared is 3, right? And these are multiplied. You're supposed to multiply these. Now, plus 6 squared is just 6, because it's the root of 6. Square with the root, cancel. Okay, so 25 3 times is 75 plus 6, and then gives me root of 81, which equals what? What's the root of 81? 9. That's the answer. Yeah? Questions? No? All right. Awesome. Well, that was the distance formula. Again, it's in the notes on Blackboard. It's right here. Yes, if you didn't get a chance to copy it. So that's the first part of today's lesson. All right. Now let's play with it a little bit. We have this question right here, which says determine if the given points form the vertices of a right triangle. Okay, so we can plot the points here. Let's try that. You have -2 and 1. So x is -2, which is 1, 2, right here. And y is 1, so go 1 up. This is A. Okay. B is 2 and 5. So 2 for x, 5 for y, which is right here. So that's B. Right. C is 5 for x, so 1, 2, 3, 4, 5, right here for x, and then 2 for y, so go up 2, and this is the point. That's C. So this is my triangle. Now let's hope that I can actually draw a straight line, because I actually can't draw a straight line to save my life. So let's see. Oops, there you go. Yay, that actually looks like a triangle. All right. Okay, so we have A, B, C, and it's a triangle. It looks like a right angle triangle, but you're not sure, right? Because the angle that looks like it's a right angle could be 89.9. So close that it could even fool you, but you're not actually sure. So unless we're going to try to find the slope or do something else like that, we are going to have to figure out how to do this. Well, I have the vertices of these points. I'm going to use them to find the distance between each two. By doing that, you end up finding what? The length of the side. Now, when you have the lengths of all 3 sides of a triangle, and it's a right angle triangle, what can you use? The Pythagorean Theorem. So we're just going to plug everything into that theorem and see if the 2 sides of the equality actually match. If it works out, then it is a right angle triangle. Okay, so let's start by finding the distance for all 3 of them. So here you go. Distance of A and B. Now I'm writing what they are so we don't get confused on which point we find the distance to. So I'm finding distance for this side right here, AB. Okay, so root of. So A is 1, B is 2. Okay, x2 is 2 minus x1, which is -2 squared, plus y2 is 5 minus y1, which is 1 squared. So now I have 2, essentially plus 2, so 4 squared, plus 5 minus 1, which is also 4 squared. So I have 4 squared twice. So that's 16 plus 16, which gives you 32. Everybody with me so far? Now, let's do a second side, I'm going to do BC. So now turn BC. So these are my points now. That's 1, that's 2. Root. Okay. Now x2 is 5 minus x1, which is just a 2 squared, plus. Now y2 is 2 minus y1, which is 5 squared. Now 5 minus 2 is positive 3 squared, plus 2 minus 5 is negative 3, but squared, it ends up being positive anyway. So you have 9 and 9 added together, that gives you 18. So this is root of 18 right here. That's the length of that side. Let's find the last one. AC, or CA, if you will. Okay. Now for this one, I'm using these 2 points, A and C. So that's my 1, that's my 2. Again, if you switch, do this is your 1, that's your 2, you still end up you'll still end up with the right answer. Okay, let's see. C is my point 2. So this is x2. So it's 5 minus x1 is negative 2 squared, plus 2, that's my y2, minus 1 squared. Okay, so 2 minus 1 is just 1. 1 squared is still 1. So this is 1. Here we have 5 plus 2, which is 7. Squared is 49. So 49 plus the 1 is 50. This is root of 50. So, okay, so these are all 3 sides. Now, if you remember, this is the theorem, right? AC is my c squared, right? Because this is the, yeah? Okay, so if I plug these, I'm going to say we have root of 50 squared equals root of 32 squared plus root of 18 squared, like that. So since every single root is squared, the squared cancels with the root. You end up with what? 50 equals 32 plus 18. Now if you add 32 and 18, does it give you 50? Yes, it does. It checks out. So this is a right angle triangle. Any questions about that one, you guys? Any at all? Okay, I'll take that as a no. Awesome. Okay. Next up, midpoint formula. This is another formula that you need to remember, but this one is even easier to remember because it's so simple. It's literally just the average of the points. That's what you're doing. When I'm asking you to find the midpoint, I'm asking you to go to 2 points that you've plotted, right? And you know the distance of, and then go to the middle and say, okay, that's the point I want. The point exactly in between those 2, right down center, right here. So the easiest way would be to know the distance between the 2 and then divide by 2, right? But the thing is, you don't want to keep doing this every time and then divide it by 2. So there's an easier way. All I have to do is look at the values, you know, x1 and x2. You add them and then divide them by 2. You take the average of the x values. x1, x2 divided by 2 is your x value for the midpoint. And notice it's already set up in the form of a point. So here are the parentheses and here's a comma. This is not an equation. Simple ordered pair. x1 plus x2 over 2, that's your x. y1 plus y2 over 2, that's your y. That way, you get your midpoint. Simple as that. Okay. Let's try this example right here. All right. So my first point is negative 1.8 for x and -3 for y. Second one, we have 4.5 for x and -1 for y, right? Okay, so the midpoint is what? x1, which is -1.8, plus x2, which is 4.5 over 2, comma, this is my x value, comma. Now, -3 plus -1 over 2. That's my y value. I took both y's and added them. Simple as that. Now, here, the addition between these two gives me what? It's -1.8 plus 4.5. If you want, you can use your calculator. This is a 5, by the way. I'm sorry if it looks weird. Yeah? It gives me about 2.7. So 2.7 over 2, right? That's 1.35. So that's my x value. Okay. What about the y? -3 minus 1, or plus 1, plus -1 is -4. Divided by 2, it's -2. That's my midpoint. So what's that? Questions? No? It's super simple. All right, awesome. Yeah. Okay, now to get to a fun part of this section, which is graphing, right? We're going to learn how to graph equations. Now, this is kind of an intro to functions. So when you see a relation like this, which is y equals a relation in terms of x, this is technically a function. But I'm going to introduce you to what functions are in the next section. Right now, we're just going to learn how to plot based on an equation that I give you, right? Now, when you have a relation like this, there's something we call the dependent variable and independent variable, yes? In this case right here, the one we're looking at, x is your independent variable, and y is the dependent variable. And here's why. Because if I want to choose values for x, I can do it randomly at will. Any value for x you want, you can just plug it in there, okay? As long as it kind of fits or works for this equation. Because sometimes they have limitations. But this one is just a quadratic, so this is a polynomial. So it can be any number you want. So we can choose any x we want. But y, however, after you choose the x value, you have to plug it in here to find out what the corresponding y is. Yes? So y depends on what x is. That's why we have the equation in terms of y. So y equals this relation specific to x. If that makes sense. So y depends on what x is. So let me show you an example. Let's say we have 0, 1, 2, 3, and then -1, -2. Okay? Those are the numbers I'm plugging in. That's my x. I chose it at will. I did whatever I wanted. Okay. Now, let's find out what y is. To do this, I'm going to grab the x value, plug it in here to find out the answer. That would be y. Okay, so when x is 0, what happens? We have 0 squared plus 3, which is 3. 0 plus 3 is 3. So y equals 3. Okay. 1, so x is 1. 1 squared plus 3 is 4. That's 4. Now, 2 squared is 4, plus 3 gives you 7, right? Okay. 3 squared is 9, plus 3 is 12. This gives me 12. Now let's look at the negatives. -1 squared is 1, plus 3 is 4. And -2 squared is 4 plus 3 gives you 7. Now notice, for the positive 1 and -1, I got the same y answer, 4, because I'm squaring it, so the sign doesn't matter. The 2's, again, you got the same answer. If I had another 3 in here, the -3, the answer would still be 12. That makes sense, okay? Now, that's actually one of the features of a okay. Oh, did the mic cut off? Oh. Can you guys still hear me? Are we good? All right, awesome. All right, now let's plot them. So these right here are your points. So This x value and that y value give you one ordered pair. This is 0, 3. These two right here, 1 and 4. These two right here, 2 and 7. 3 and 12. Negative 1 and 4. Negative 2 and 7. So those are my pairs. Now let's plot them. All right, here you go. First one, 0 and 3. So this is a 0 for x. We go 1, 2, 3. 3 for y. This is the point 0, 3 right here. Okay, next one, 1 and 4. So 1 for x, 4 for y, which is right here. 2 and 7. 2 for x. This is 4, right? 5, 6, 7 for y. It's right here. 3 for x, 12 for y. Okay, so it's 3 for x. The number here of 12 is over there, so I'm just going to put it right here. All the way up top. That's 312. Okay. Next we have negative 1. So we're going to the negatives now. Negative 1 and 4. So 1, 2, 3, 4. Right here. Negative 1 and 4. Again, 4 for y. And then you have negative 2 and 7. So negative 2 and 7, just right here. So can you guess what negative 3 is going to be without us actually solving it? It's going to mirror this one, right? Do you notice the pattern? So 3 is right here, and it's going to be 12. Like that. Questions? Okay. Now it looks like a big U, like a bowl, right? That's the parabola. That's the graph of a quadratic. Now let me actually try and graph it, and let's hope it comes out right, because I am horrible at graphing. And here's the funny part. I actually started learning how to sketch recently. Yeah, good luck with that. All right. So here's my parabola. Imagine the line is even. And on the test, by the way, I don't expect you to actually be able to do this like straight line. No matter how wonky it is, it's fine. Although, since most of it is going to be multiple choice, you don't have to worry about graphing. All right. Questions? Did everybody understand that example? How we plotted the points, graphed them? Okay. Awesome. Now, before we move on, let me show you the page of my solution, because it actually has the neat function, because I just wanted to see what it looks like if I could draw. All right. It's supposed to be even like that. Okay, and notice, mirrored. This is the one you guessed. All right.
I do have one question.
Go ahead.
So will it always give us the x? Like, will we have to put in the x, the x and the y's, or would it give us like I guess the numbers already?
For x, you mean?
Well, just depending on which one it gives us. Like,
It doesn't give you anything. That's the thing, though.
Oh, okay.
Yeah. So yeah.
Okay.
So what you do is pick numbers for the independent variable, right? And then find out what the dependent's going to be based on that value. If that makes sense.
Okay.
Yes. So I chose 0 for x, and then now I have to find out what y would be when x is 0. So I'll be able to plot that point. Make sense? It's just that you have to make sure that you abide by the limitation the relation has. And I'm going to show you an example that actually has a limitation next. Okay? Now, let's see. Let's look at one. Okay? Here you go. This one right here. So, radical. Okay? We have a root. So, over here we have y equals x plus 3. Now, this one does have a limitation. Because remember when I mentioned how imaginary numbers work with equations, but when we're going to start dealing with functions, we need to deal with real numbers, right? So if you get something that's supposed to be an imaginary result, that's technically undefined, like mathematically it's not there, right? Because again, they're imaginary. So for this one, a root can't have a negative value underneath, right? We can't have a negative root or negative inside of the root. So you need to avoid the values that turn this to negative. So what's the smallest number I could put here that would actually work, right? So that would be y becoming 0. What would turn this to 0? The smallest number you can use is what? -3, right? Because if I put -3 in here, you're going to have -3 plus 3, which is 0. So -3 works because it gives you 0. But if you use -4, you're going to get -1, and that's I. You can't do that. Make sense? So you can't, for x, you can't go below -3. Does that make sense? So when you're choosing your x value, you have to go, okay, so it's -3, -2, -1, 0, 1, 2. You can't go any lower than -3. Make sense? So you choose based on that. Now you can choose something higher if you want, but again, mind the little graph area I have because the limit is 6. If you get too big a number, you might not be able to graph it here. But if you have graphing paper, go for it. Okay? But anyhow, so let's see. Now I chose these numbers for x. I'm going to plug them in here to find out what y equals, and then I'm going to write the y's down here. So let's see. So now I want you to help me with this because I don't have my calculator, right? Let's see. -3 under the root, we have -3 plus 3, which is 0. Square root of 0 is just 0, right? So the answer here is 0. Sorry. My throat is acting up today. Okay. Next up, we have -2. So -2 goes in here instead of the x. We plug it in. So you get -2 plus 3, which is +1. So the answer is +1. +1 under the root is just 1. Square root of 1 is 1. So the answer here is 1. Now we have -1 plus 3, which is +2. 2 under the root gives me square root of 2. You can't really simplify that. 2 is a prime number. Yeah. Now 0. 0 plus 3 is 3. 3 under the root is still 3. Under the root. Like that. You can't simplify that either. Okay. 1 plus 3 gives me 4. Now 4 under the root is 2. So the answer is 2. 2 plus 3 is 5. 5 under the root gives you square root of 5. Oops. So far so good? Now, let's come up with the ordered pairs. So you have -3 and 0 here. -2 and 1. -1 and square root of 2, which is like 1.14, right? 0 and square root of 3, which is like what, 1.7, I think. If you have your calculator, you can confirm. Actually, please do, because to make sure I got it right. Yeah, okay, good. So we have 1 and 2 over here, and then 2 and square root of 5, 2.32. I think it's 2.2. Yeah, okay, good. So those are my values. Now let's plot. Okay, here we go. -3 and 0. So x is -3. We go to the negatives. 1, 2, 3. And then 0. So we stay on the axis. This is my point. Right there. All right, next one. -2 and 1. So -2, +1. Right here. Okay. Next up, -1 and 1.14. Okay. Let's skip that one a little bit and do this one first because it's, solid integers. We have 1 and 2. So this is 1. This is 2 right here. Okay. Now I'm going to go back. Anyway, -1 and 0.14. So -1, this is 1 for y. I want 14, so let's do it like right here. That looks about right, I think. Right? Now, 0 and 1.7. So 0, so right there. 1, this is 2, so a little below. So maybe right here. This is 1.7, maybe. Okay. We already did this one, which is 1, 2. And then we have 2 and 2.2. So 2, this is 2 for y, 2.2 would be right here maybe. Like that. That's my graph, right? So do this a little bit. So it looks like this. That's the graph of a radical. This is x plus 3. Any questions, you guys? Any at all? All right, awesome. Let's do one more, yeah? Number 9. We're going to graph an absolute value. But notice this time I have x equals the absolute value in terms of y, which means what? Which one is my independent variable here? Which one do I get to choose for? It's y, because it can be whatever it wants to be. Yeah, and x depends on whatever y is. Okay, so we're picking y. We're going to pick y. Right. So over here. Now again, because it's absolute value, I guess it doesn't matter which number you use. It's still going to be, same thing. So let's see. I'm going to use 1, 2, 3, 4, 5, 6, just to make it easy. Yeah, just all normal numbers. Okay, I'm going to plug them in here and find the answer. Let's see. 1, which is y, 1 minus 4, so -3 inside the root. Sorry, not the root, inside the absolute value. And the absolute value of a negative number becomes positive, right? So the answer is just 3. Okay, next, 2. 2 minus 4 is -2. -2 inside the absolute value is positive. Positive 2. Okay, 3 minus 4, -1. -1 inside the absolute value gives you 1. All right. Now we have 4 minus 4, which is 0. Absolute value of 0 is still 0. 5 minus 4, 1. Absolute value of 1 is 1. 6 minus 4 is 2. Absolute value of 2 is 2. So all good. All right. Now let's do my pairs. We have 3 and 1. 2 and 2. Right? 1 and 3. 0 and 4. 5. Oops, no, I mixed it up. 1 and 5. 2 and 6. Okay. Now let's plot. Here you go. X is 3. 1, 2, 3. Y is 1. So it's right here. X is 2. 1, 2. Y is 2. It's right there. X is 1. Y is 3. So it's right there. X is 0. Y is 4. Right here. X is 1. So again to 1. But Y is 5. So it's right there. Okay. X is 2 again. So 2. But Y is 6. So we go up one more. Y is right there. And the graph of, so let me try and draw a straight line. Looks like this. This is my graph. Yeah? Now, if this had been y equals the absolute value of x minus 4, yes? So like normal setup where x is the independent and y is the dependent, then this V shape would have been upside instead of sideways. It ended up being sideways because it was written in terms of x instead of in terms of y. So if it was like this, the V would have been like that. Instead. That's the graph of the absolute value. Any questions, you guys? Yes, no. Now, when it comes to functions, awesome. Okay. Now, when it comes to functions, usually it's written in terms of y equals something in terms of x, like this. If I give you a function or a relation, I should say, where x equals something in terms of y, this is not a function. But we'll get to that tomorrow because it's part of tomorrow's lesson. Okay? So anywho, so everybody got graphing, plotting points, all that table? All good? All right, awesome. Now, let's go to intercepts. All right, here we go. This is number 11. Okay. So the idea of the x and y intercepts is that they are the points where the graph of the function, or the relation, touches or intersects with the x and the y axes, right? Now, as a rule, when it comes to functions though, just for functions, as a rule, you can only have one y-intercept and more than one x is fine, but the max you can have for y is just one. But don't worry about that now since we're not dealing with functions yet. Okay, so let's look at the graph and see what are my x and y intercepts. So again, for x, it has to be the point where the graph touches the x-axis, and for y, it has to be the point where the graph touches the y-axis. So where does it touch the x-axis? Right here, this point. Just 1, 2, 3. I mean, it's a circle, so it has the same diameter. If it's 3 here, it's going to be 3 here. But it's the point 3 for x, right? So this is 3 for x. But what's y at this point? When the number is on the axis. That means y is 0 because we didn't go up and down, right? So the point is 3, 0, like this. When I ask you for the x-intercept or the y-intercept, I'm asking you for an ordered pair. Okay, so you give me 3, 0. Now what's the y-intercept? It's right here. That one. Add 3 for y. It's 3. So what's x? We didn't go right or left, it's just here. You just went up. So x is 0. As far as x is concerned, it's still 0. So it's 0, 3. So notice that when we're dealing with the x-intercept, y is 0. And we're dealing with the y-intercept, x is going to be 0. And that's always. Otherwise, it's not going to touch the axis, right? So for the x-intercept, y is 0. For the y-intercept, x is 0. So for each of them, the other one is 0. Okay? Let's look at this one. How many x-intercepts do I have here? 1, 2, right? I have 2 of them. Okay, this is a point 1, 2. So this is at x equals 2. It's -1, -2. So it's 2 and -2. But don't give me the answer like this. Do that. Okay? It's 2, 0 and -2, 0. Y is 0 for both. But give it to me as 2 pairs. So I have 2 x-intercepts, which are the point 2, 0 and -2 and 0. What's my y-intercept? We only have the one right here. This is the point that's -4 for y. X has to be 0. So 0, -4. Yeah? Any questions on that one? Okay, good. So this right here is how you find the intercepts from a graph. It's pretty simple. Just look for the point, and that's it. We're done. Now let's see how you can find it algebraically with no graph. If I just give you a relation or an equation, and I tell you, give me the x and y intercepts. Well, this is where the concept comes into play. We said that the x-intercept has y equals 0, and the y-intercept has x equals 0. So when you're trying to find one of them, you set the other variable to equal 0. For example, right here, if I'm finding the x-intercept, y is what? 0, right? So I'm going to grab this equation right here, and I'm going to plug in 0 for y. So this equation becomes 0 minus x squared equals 9. Now it's easy to solve. You only have the one variable. Okay, so I have -x equals +9. If I multiply both sides by -1, right? So multiply this by -1, you get what? X squared equals -9. Now we have a problem. Because if I take the square root of both sides, what happens? We have a negative value under the root. So this is unsolvable. Yes? So since this is numerically unsolvable, like from math, you don't have a real solution to this. It's going to give you a complex. So that means that there is no x-intercept. Right? There's one. We don't deal with complex or the imaginary numbers. Okay? So no x-intercept. Now let's look for the y-intercept. So in terms of the y-intercept, x has to be 0, right? The other one has to be 0. So here's my equation. Y minus x is 0, right? So 0 squared equals 9. 0 squared is still 0, so this doesn't matter. Basically, y equals 9. Simple enough. If you stop here, you didn't do everything. This is not the final answer. What is the answer I'm looking for? It needs to be a pair. It's 0, 9. This is the y-intercept, right? If you find the y value for me, you just told me what the y value is. You didn't tell me what the intercept is. Even though it's obvious, because we know it's 0 for x, 9 for y, you still have to write it down. Everybody with me so far? All right, good. Okay, so let's do this one. Okay, over here, we have x equals absolute value of y minus 3 plus 2. So first, we're finding the x-intercept. So for the x-intercept, y is what? 0. Okay, with that knowledge, let's plug it in. So x equals absolute value of 0 minus 3 plus 2. Okay, so this is negative 3 inside the absolute value, which is positive 3 once you take it out. Plus 2 becomes 5. X is 5. Which means that my point is what? 5, 0. That's my x-intercept. Okay, that's done. Let's do the y-intercept. For the y-intercept, x is 0. All right. Now, we have the absolute value of y minus 3 plus 2, and it equals x, which is 0. Like this. Okay. Now, to solve the absolute value, the rule is move everything you have to the opposite side. Isolate it. So the 2 moves here and becomes negative. So you have negative 2 equals the absolute value of y minus 3. Now, what did we say about the fact that absolute value equals a negative? This can't happen. The absolute value result should always be positive. Therefore, this is not an acceptable situation. There's no solution here. Therefore, there's no y-intercept. Yes, there's a one. Any questions? Did everybody follow this one? Okay, let me take out the S. Are you guys still with me? I didn't cut off, did I? Just to make sure. I think we're good. Yeah, all right, good. Last one, and then I'll let you go. Okay? This one right here. Okay, we're going to find both x and y. Let's do x-intercept. Y is 0, because we're finding the x-intercept. So we have x squared over 9 plus 0 plus 3 squared over 4 equals 1. All right. This is a number, 0 plus 3, which is 3. 3 squared is 9. So you have 9 over 4. So here we have 1/9 times x squared plus 9 over 4 equals 1. So I'm going to grab the 9 over 4 and move it to that side. Turns negative. We have 1/9 x squared equals 1 minus 9 over 4. Now subtraction between these two gives me negative 5 over 4. If you didn't follow that one, simply turn the 1 into 4 over 4, just to have the same denominator, right? 4 over 4. And then 4 minus 9 gives you negative 5 on top. The denominator is the same. Yes? So 4 minus 9, 5, and the bottom is unified, so it's just 4. So was it good? So now we have negative 5 over 4 on this side, and we have 1/9 times x squared. Next, I'm gonna let me rewrite that. Okay, next I'm gonna multiply both sides by 9. The whole thing times 9 to get rid of this 9th. So 9 times a 9th, they disappear. You just have x squared equals, and 9 times negative 5 is just 45 over 4, and it's negative. Now, x squared equals a negative value. This can't be solved, right? Because if I take the root, you'd be taking the root of a negative answer. A value squared must be positive, therefore it can't be negative. There's no x intercept. Yeah? So there's one. Now let's do y. And I think I ran out of room. I'll do it on the other side, right? Let me just copy the question over here. It's x squared over 9 plus y plus 3 over 4. Oh, this is squared. And it equals 1, right? This is the question we have. Now, let's do y-intercept. Now, for the y-intercept, x is 0. So x equals 0. Let's plug that in here. So you have 0 squared over 9 plus y plus 3 over 4. This thing squared. That equals 1. Now, 0 squared is 0. 0 over 9 is still 0. Yes? This is just 0. So that goes away. We don't care about that one. We have 9 plus 3 squared over 4. And it equals 1. Okay. Well, first thing I need to do is get rid of this 4. Oops. Equals 1. Now I'm going to multiply by 4 here and multiply by 4 here. These cancel. I got rid of the denominator. And 4 times 1 is 4. Yes? So you have y plus 3 squared equals 4. Now I take the root. Take the root. 2 with the root cancel. Square the root. And you get what? Y plus 3 equals positive and minus, or positive and negative, 2, because that's the square root of 4. Yeah? Now moving this 3 right here turns it negative. So y equals what? Negative 3 plus or minus 2. Right? Which basically is what? If it's negative 3 plus 2, it gives you negative 1. And if it's negative 3 minus 2, it gives you negative 5. Those are my y values. But you need to give me the points. So it's 0, negative 1, and 0, negative 5. Those are my y-intercepts. Any questions, you guys?
Can you explain why we did it a plus or minus again?
This one right here?
Yes.
Because I took the root. When you take a square root of a number, you have to account for both possibilities, whether it's plus or minus.
Okay.
Right? Yeah. Like, because, you see, square root of 4 gives you 2. But the thing is, you don't know if this was positive 2 or negative 2 that got squared. If that makes sense. Right? So, you account for both. All right? Questions? All right, you guys. If there are no other questions, you are good to go. Have a good evening.
Oh, wait, actually, sorry, I had a question.
No problem. What's up?
About the lockdown browser, I know you wanted us to do like the
Nice.
camera one, but I don't know where to like, because I had already done like just like the one you posted about. I don't know if you're
Yeah.
gonna like post another one or where I can like do
Oh
it.
no, I just updated it. Like it's the same one. You should have been able to see it on Blackboard this past week.
Oh, okay. I'll
Just
go
go
look
in
at it.
there. I'll make sure it's open for another week. But yeah, please go ahead and do it again. Just get in there. Make sure that you can see the question. Everything's okay. But now that I enabled the camera, it's actually going to ask you to do a bunch of checkups because it's going to do the same thing when you're taking the test, right? It's going to ask you to to see you, to do a room check, environment check, to just like rotate to make sure there's nobody around and that you don't have any books open and stuff, right?
Right.
That this is going to ask you for an ID to make sure that you're the person who's taking the class, that kind of stuff.
Mhm.
And the college is mandating it, so it's actually not me who wants to do this, but hey. So if you have a problem with your laptop or you don't have a camera, now would be a good time to tell me because we might have time to deal with it or find a solution. But
Okay. Can I do it?
otherwise, we're good to go.
Yeah, I could just go ahead and do it later. Thank you.
Okay,
Have
sounds
a good
good.
night.
You too. Right. Bye, everyone.